Okay, everyone. So let's start with this. We will be doing some papers complete, and for others, we will only be doing the difficult questions. So today, we will be doing this complete paper, November 2023, paper 3, variant 1. And on Saturday, in our next class, we will be doing the difficult questions from the other two variants from this session. Okay, now we have gone through the instructions once when we had our introductory class. We looked at the key instructions that we are given here. These are the important things that you need to remember, that in your working and in your answer, this is the minimum level of accuracy that you need. In fact, in your working, it should be more accurate. For working, minimum 4 significant figures in general, and for degrees, minimum 2 decimal places. And for answers, this is the minimum level of accuracy that you should use in general throughout this paper, unless a question specifies something else. And this is extremely important in paper 3 because a lot of students end up writing down the final results without showing complete working, and that results in loss of marks. So you need to make sure whatever you do, you show complete working for that. Do not skip steps, okay? Especially for quadratic equations, for instance, do not write down the answers directly. At least input values in the quadratic formula or show the factorization steps. You need to remember that. All right, so these are the standard instructions that you have in every paper. We have discussed them in detail earlier. I'm not going to go through them every single time when we do papers. So we will jump into the paper directly from next time onward, okay? Now, while we're doing questions, since this is our first P3 session, those of you who are not in any of the other session, let me just remind you. Let me just tell you about this, that in the participants list, you would see an account by the name of so let me actually change this name. In the participants list, the account that says message here, if you want to send something to me in writing, if you want to send a message in the chat box, please make sure that you send that to this account. Okay, it does not get saved. Because otherwise, I would not be able to see that during class. So any message that you have to send, make sure that it is sent to this account, the one that says message here. Okay, because I can see that on my other device. Otherwise, if you send it to the one that has my name on it, the full name on it, I will not be able to see that. Okay. And then since we would want to not go over time by a lot, we would want to cover it complete the paper by around 7 p.m. or maybe slightly before that. What I'm going to do is I'm going to keep doing the questions. If you have any question, if you have any problem at any point, please make sure that you raise your hand or you write your question in the chat box. If you don't do that, I'm going to assume that you understand what we are doing. All right. So if you think at any point you do not understand something, make sure to raise your hand or write your question in the chat box. Okay. So that I can respond to your question. Okay, now let's start with this. This is the first paper that we're doing. We're doing this. We're going to do this paper completely. Let's start with the first question. It says, find the exact coordinates of the points on the curve at which the gradient of the tangent is equal to 8. Okay, so we have some curve. We don't know what the shape of the curve looks like. Let's say it's a curve like this. There's some point at which it says the gradient is equal to 8. So let's say it's this point. The gradient of the tangent is equal to 8. Now, what does that mean? Gradient of the tangent at any particular point is the same as the gradient of the curve at that point. So all we have to do is we have to put the gradient of the curve equal to 8 in order to find that point. Okay. Now, how do you find gradients of curves? Gradients of curves are found by differentiating. So you have this curve, you would just find the derivative of this curve, put that derivative equal to 8 because the gradient of the curve at that point is supposed to be equal to 8. So that's all that you've got to do. So how do you start? You start by differentiating this curve. It's a fraction. How do you differentiate fractions? You can use the quotient rule. You can say this is u, This is V. What's the quotient rule? Quotient rule. It looks like this. It's VU dash minus UV dash divided by V squared, right? When differentiated, this is what you end up getting. What's the derivative then? V as it is, that means 1 minus 3x as it is into derivative of u, which is 2 times x, minus u as it is. What's u? U is x squared into derivative of v, 1 minus 3x. What's the derivative of that? Derivative of 1 is 0. Derivative of minus 3x is minus 3. So you have x squared into minus 3 here. In the denominator, you have v squared. That means the square of the denominator. That's 1 minus 3x whole squared. That is going to be the derivative of this function. Okay. Now, since the gradient is supposed to be equal to 8, we say the derivative represents the gradient function. We put the derivative equal to 8. Okay. And we get this equation. This whole thing that equals 8. And from this, we can find the value of x at this particular point. Okay, let's see what this turns out to be. Let's simplify the numerator. 1 into 2x, that's 2x, minus 3x into 2x, that's minus 6x, plus 3x squared in the denominator. We have 1 minus 3x whole squared. You could actually just take it to the left side and multiply it here. Or let's do it in the next step. Let's expand it here. A minus b whole squared, what's that? A squared minus 2ab plus b squared. So this is going to become 1 minus 2 into 1 into 3x, that's minus 6x, plus 3x whole squared, that is 9x squared. Now this thing goes to the left side, gets multiplied by 8, and you're going to get 8 minus 6 into 8, that's 48. 48 times x. 9 into 8 is 72. 72x squared, that equals 2x minus 6x plus 3x squared. Now take everything to one side. It's a quadratic equation. Just solve that quadratic equation, okay? And see what you get from that. 72x squared minus 3x squared, that's going to give you 69x squared. Bring the x terms to the left side as well. You have minus 4x here. When that comes to the left, it becomes plus 4x, minus 48x plus 4x. That's going to be minus 44x plus 8 equals 0. This is the equation that you've got on the left side. Okay. Now, you can see if it can be factorized, but these are large numbers. What you can do is you can use the quadratic formula directly, input values in the quadratic formula, and then you can write down the answers after that. It looks kind of weird, the equation. So let me just check this working as well. So by the way, just a disclaimer, I have multiple screens here, so it's a lot of distraction. So I will at times be making careless errors. So please make sure that you're very active in checking my working as well. If there are any careless errors somewhere, please make sure that you point them out. Okay, I think there is one already, but let me just check. So we have 1 minus 3x whole squared, 1 minus 6x plus, that's all right. I think the derivative looks okay. 1 minus 3x into 2x minus x squared into minus 3 divided by this. Okay, derivative looks okay. Multiplication, 1 minus 6x plus 9x squared, 8 minus 48x plus 72x squared. That's giving us this 2x minus 6x in the numerator. We have 2x minus, yeah, so this looked weird. So basically, when we multiply this thing, 1 into 2x, and then minus 3x into 2x, that should have been 6x squared. And then you have plus 3x squared there, minus 6x squared. So this is supposed to be squared here. Let me just correct this. So what does this become? 72x squared plus 6x squared minus 3x squared. That's going to be 75x squared. And then you have minus 50x plus 8 equals 0. Okay, so that looks relatively better. Let me see if we have any result from this. 75x squared minus 50x plus 8. Let's solve this and see what we get. Now, if you can't factorize it, what you should do is just input values in the quadratic formula. So how do you do that? Minus into minus 50 plus minus square root of minus 50 whole squared minus 4 into 75 multiplied by 8 divided by 2 into A. Okay, 2 into 75. Now, this is the least amount of working you should show. After this, you can write down the answer, and that's perfectly okay. All right, you can see what this turns out to be. Now, you can use the equation solving function in your calculator, but still just show this particular step. You will get the answers from that. Now, let me just do that on my calculator. We can also speed up the process a little, because when we do complete papers, and I'm trying to explain this as well, what you should do is, please do the calculations alongside me so that we can speed up the process a little, okay? So that I don't have to do the calculation and I can just see what the answers that you're sending me, if they match, hopefully. That will be correct. We can speed up things a little this way, and we'll be able to complete the papers in relatively less time like this, okay? So what do we get from this? I was expecting an answer by now, but let me just try it. It's an equation. It'll be easier if you can just write them down in the chat box so that I have multiple answers there. I can just verify them as well. If multiple people are giving me the same result, that kind of will tell me that it's correct. Okay, so yeah, so one of you is telling me minus 2 over 5, another is telling me 2 over 5, then minus 4 over 15, 4 over 15, 2 over 5, minus 4 over 15. Okay, so you're telling me it's 4 over 15 and 2 over 5. These are the values of x that we get, 4 over 15 and 2 over 5. Okay, most of us, it's probably positive because the others are saying positive, so it's most likely positive. Okay, x equals 2 over 5 and x equals 4 over 15. These are two values of x that we're getting. How do you find the corresponding values of y? We've got this function, put these values back in the function, and you'll get the result. Y equals x squared divided by 1 minus 3x. Input these values in the function. What do you get? Y equals 4 over 15 whole squared divided by 1 minus 3 into 4 over 15. That's going to give you one value of x. Then you input 2 over 5. That's 2 over 5 whole squared divided by 1 minus 3 into 2 over 5. And you will get a result from this. What are the values of y that we get? What are the values of y? Okay, so one value that I'm getting is 16 over 45 from the first one. And then 2 over 5. 1 minus 3 into 2 divided by 5. Okay, what's the second one? Minus 4 over 5. Okay, good. Minus 4 over 5. That's the other value that we're getting. Now, what did they ask us? They asked us for the exact coordinates of the points. So now you should write this in the form of coordinates. One coordinate is 4 over 15 and 16 over 45. And the other point, the coordinates of the other point are 2 over 5 and minus 4 over 5. These are the 2 points that we have. These are the points at which the gradient of the tangent is equal to 8. Okay? Abdullah, the question says, gradient of the tangent is equal to 8. If the gradient of the tangent is equal to 8, that means the gradient of the curve at this point is also going to be equal to 8, because the gradient of a curve at a particular point is the same as the gradient of the tangent at that point, right? So all we're doing is finding the gradient of the curve. The derivative gives us the gradient of the curve and putting that equal to 8. And then we solve that equation, find the value of x, we get the corresponding value of y from that. Okay, I hope that makes sense. All right, okay, let's move on. Part 2. Question number 2. Now it says, on an Argand diagram, shade the region whose points represent complex numbers z satisfying these two inequalities. We have one inequality here, another inequality here. We need to shade the region whose points represent complex numbers z satisfying both of these inequalities. Now, how do you Mustafa, you should not write them in decimals because the question says it has to be in exact form. So you can't use decimals. It has to be fractions. Okay, when it says exact, you don't use decimals. Okay, now what about this? We have two inequalities. Remember, first of all, what we have to do is we have to convert them to standard form. Remember what the standard form is? For modulus, you want z minus something, and for argument as well. Inside the argument, you want something like this, z minus something. This is the standard form for the modulus and for the argument. You want to convert these to this form first of all. Okay, now, first inequality, z minus 2 iota. It's already in this form. You don't have to do anything with that. This one is not in that form. You have to take minus common from 2 minus iota to first convert it to that form. Okay, so it becomes z minus 2 iota less than or equal to modulus of z minus, take negative common. That leaves you with minus 2 plus iota inside. That is what the first inequality becomes. Now, what about the second one? Is this in standard form? This is also not in standard form. Inside the argument, we need a minus after z. So this could be written as z minus minus 1. Take minus 1 common from this to convert it to standard form. Okay. And now this argument is between 0 and pi over 4. Now let's understand what these locus are going to be, what these loci are going to be like. Let's draw an Argand diagram. So this is what the Argand diagram looks like. We have the imaginary axis here. We have the real axis here. Remember, whenever you draw Argand diagrams on both axes, you should take the same scale. Whatever is representing 1 unit on horizontal axis, it should be the same on the vertical axis as well. Okay. So now let's say this is 0. And then we have maybe 1 here. Approximately the same distance should be 1 on this side as well, this side as well, and on this side as well. Then you have 2 here, 3 here, 4 here, 2, 3, 4, minus 2, minus 3, minus 2, minus 3. Okay. Now, what does this first inequality mean? Remember this notation. What does it mean? Distance of z from 2 iota. The point is 2 iota. It means distance of z from 2 iota. That's what it means. That is supposed to be less than or equal to distance of z from this point, which is minus 2 plus iota. So we're talking about 2 points. There are 2 points. Z is such that from one point, its distance is less than that of the other point. Okay. Now, what are the 2 points? 2 iota and minus 2 plus iota. So the first thing you should do is you should mark these 2 points. 2 iota, where is that point? That point is here on the imaginary axis. This is 2 iota, where you have 2 here on the vertical axis. This is 2 iota. And the other point is minus 2 plus iota. That's 2 units to the left and 1 unit up. The other point is going to be here. This is the other point. 2 points, the distance from these 2 points is what we're talking about. Remember, whenever you have 2 points, the locus that you get is a perpendicular bisector of those 2 points. So this is the this is point 2 iota. This is point minus 2 plus iota, and this is 2 iota. These are the points that you have marked here. You first have to draw a perpendicular bisector. Whenever we talk about 2 points, the locus that you draw is a perpendicular bisector. How do you draw a perpendicular bisector of this? You could use a compass like you used to do in O levels, make 2 arcs on both sides, and then after that, you join those 2 points where the arcs are meeting. Or since it's a sketch, you could draw the perpendicular bisector directly using a ruler as well. The way it works is you find the midpoint of these 2 points. Since one point is at 0 and the other point is at minus 2 on the horizontal axis, where is the midpoint going to be? The midpoint is going to be at minus 1. So when you join these 2 points, At -1, you would have the midpoint. And then you can draw a perpendicular line to the original line such that it's passing through this midpoint. So draw a line that's perpendicular to that first line such that it's perpendicular to that first line. It's going to look something like this. This is the line that you draw. This is perpendicular bisector of those 2 points. Okay. And now what does it say? Distance from 2i is less, and the distance from -2 plus iota is more. So the point that has less distance from z, that should be closer to z. So z should be towards the point that has less distance from it. Distance of z from 2 iota is less, distance of z from -2 plus iota is more. So it should be far away from -2 plus iota, and it should be closer to 2 iota. Which side of the perpendicular bisector are we going to shade? The side towards 2 iota. It's going to be on this side. Okay. The point z is going to be to the right of this perpendicular bisector. It's going to be closer to 2 iota because the distance from 2 iota is less. Okay. You can also kind of remember it this way. Wherever the inequality sign is pointing, that is the side that you shade. Where is the inequality side pointing? And inequality sign is pointing towards 2 iota. So the side of the side on which 2 iota is, that is the side that you shade. Okay. So the right side of this perpendicular bisector is what you will be shading in this case. Okay, now that's not all. We also have to consider the second condition now. What's the second condition? Z minus 1. So what's the point that we're talking about? We're talking about point -1. Let's mark this point -1. Where is the point -1 going to be? It's a real number. Imaginary part is 0. Real part is -1. So -1 is going to be right here. This point. This is -1. What does this statement mean? Argument of z from -1. Angle is going to be measured from the line from the point -1. From the point -1, the argument is between 0 and pi/4. What you do is you draw a horizontal line at the point -1 and measure angle from there. Now the first angle is 0. 0 means that's exactly on this line. So that's going to look like this. One extreme is 0. That is going to look like this when the angle is 0. And the other one is pi/4. Remember what pi/4 is? In degrees, pi/4 is basically 45 degrees. Now, this is a very important angle as far as loci are concerned. Whenever the angle is pi/4, you have to be very careful when drawing this line of 45 degrees, pi/4 or 45 degrees. What that means is the gradient of the line is basically 1. 45-degree line is basically exactly diagonal like this. Gradient 1. What that means is when you draw this line, since the gradient is 1, whatever is the distance that the line covers horizontally, it should cover the same distance vertically. Even if you're not using a protractor for this, for drawing this angle, what you should do is you should remember whatever distance the line covers horizontally, it should be the same distance that it covers vertically. Now, what does that mean? It starts from this point. If it goes 1 unit right, it has to go 1 unit up. That means it has to pass through this point. If it goes 2 units right, it has to go 2 units up. That means it has to pass through this point. So it's important that it passes through these points. Even though it's a sketch, examiner expects that it's passing through the correct points on your diagram. So this line has to go through the point 1 here on the imaginary axis. Now this angle is pi/4, this angle is 0. Since the argument is supposed to be between these two values, that means, okay, I'm sorry, that got erased. The perpendicular bisector. I hope I can get back to that. How did that get got erased? Okay, no. I have to draw that again now. Sorry. Perpendicular bisector. What did the perpendicular bisector look like? It was something like this. OneNote actually has a problem that it moves around when we use a line tool. So that's why it's moving around like this. So this is the perpendicular bisector. We have to be to the right of this perpendicular bisector. And then we have these two angles, these two lines, one at an angle of 0 degrees that we have drawn here, and one at an angle of 45 degrees. As we discussed, it has to pass through this point, one here. So you have to be to the right of that perpendicular bisector, and between these two lines, one that has an angle of pi over 4 and the other that has an angle of 0. Now, what part of this diagram satisfies all of these conditions? To the right of the perpendicular bisector, and between these orange lines, it's going to be this part. This is the part that you're going to shade there. This satisfies all of these conditions. Okay, this small part, this triangle, make sure that that is not shaded, because this is to the left of the perpendicular bisector. That will not be shaded. The part on the right side there is what is going to be shaded. Okay, that's the part that you shade. Make sense? Okay, let's move on. Let's move on to the next one. That was question number 2. Question number 3 now. The variables x and y are related by the equation y equals ab raised to power x, where a and b are constants. The diagram shows the result of plotting ln y against x. What does that mean? Ln y is on the vertical axis, x is on the horizontal axis. You can see that. The coordinates of these points that are shown in the diagram, they're given. They are 1, 3.7, 2.2, and 6.46. Now remember, these are not values of x and y. These are values of x and ln y, because on the vertical axis, you've got ln y. Okay, keep that in mind. Use this information to find the values of a and b. Now, how did you used to do that? You have y equals ab raised to power x. Now, what does the question say? ln y has to be on the vertical axis. X has to be on the horizontal axis. The straight line is going to look like this. Y equals mx plus c. On the vertical axis, what do we need? We need ln y. So in place of y on the left side, you need ln y. And in place of x on the right side, you need x plus c. You want to convert this particular equation to a form like this, such that in place of y, you've got ln y. In place of x, you've got x. Now, how do you do that? You can take log on both sides. Take log on both sides. That leaves you with ln y equal to ln of a b raised to power x. Okay. Now, on the right side, you can use the power law. X comes down. No, you can you use the power law? In fact, that's a good question. Can we use the power law here? Can we use the power law to bring x down? Can we do that?
Sir, we have to separate log.
We have to separate it first. We could do that if the power was on top like this. If the power was here, then we could apply the power law. But for now, we can't, because the power is only on b right now. We would first have to apply the multiplication law to break it down. It's multiplication inside log. Outside log, it becomes addition. So this can be broken down like this: ln a plus ln b raised to power x. And now it becomes ln y equals ln a. X comes down here, using power law, gets multiplied, and you have x times ln b here. Now you can rearrange it to write it in this form. And that becomes ln y equals ln of b multiplied by x. I've written this term first, plus ln of a. Now let's compare it with that form. Compare it with y equals mx plus c. What do you get? In place of y, you have ln y. That's what you wanted. You've got that. On the right side, in place of x, you've got x. That's also sorted. What's the gradient of this graph? The gradient of this graph is ln b. What about the intercept, the vertical intercept? That is ln a. Now we can find the gradient of this graph. Put that equal to ln b. That's going to give us the value of b. And then we can find the vertical intercept of this graph. We could draw that. We could do that by sketching this. That's one possibility. Or we could do it by calculation as well, because we've got these 2 points given. We could find the value of c and then equate that to ln of a. Now let's try doing this. We have 2 points given, 1, 3.7, and 2.2 and 6.46. Let's use those 2 points to find the gradient and see what that turns out to be. Gradient using these 2 points is going to be 6.46 minus 3.7 divided by 2.2 minus 1. What do we get from this? Anyone? (2.3). So the gradient turns out to be 2.3. Okay. What that means is, since the gradient is 2.3, ln b, which was the gradient, is equal to 2.3. And we can find the value of b from this. How do you do that? Base of ln is e, right? Ln is the log with base e. E will go to the other side, become the base of 2.3, so that it becomes b equals e raised to power 2.3. That's the value of b that we get. Now, they've not asked us to give an exact answer, so we can just write it in decimals. E raised to power this number, what does that give us? E raised to power 2.3, that's 9.974. This is the result that we get from this. Okay. Now you can leave it like this. No need to round it off because they haven't really specified any level of accuracy. You can write more decimals and that's perfectly okay. Now what we can do is we can find the y-intercept. How do you do that? You've got this equation, y equals mx plus c. You could either use this or you could use this. You could use any of the two. If we use y equals mx plus c, for instance, what do we know already? We know the gradient. The gradient is 2.3. We can input a point here. We can input 3.7 and 1, for instance. That will give us the value of c. 1.4, right? 3.7 minus 2 to 1.4. C is 1.4. Now, since c is 1.4, c was ln of a, we can say ln of a now equals 1.4, and the value of a equals e raised to power 1.4, and that turns out to be 4.055. A equals 4.055, and this is what we were looking for. We were looking for the values of a and b. That's our final answer. Okay. Yes, Faizan?
So how did we know that there was a straight line between ln y and x?
How do we know there was a straight line between L
The
and Y and
graph was
X?
a straight line.
Okay, yeah, so that's a good question because the graph is not drawn here. They've just shown us two values. How do we know that it's a straight line? Well, when we convert it to this form, you can see it's y equals mx plus c form. Since we can write it in y equals mx plus c form, such that in place of y, we've got L and y. In place of x, we've got x. Since it is this form, y equals mx plus c form, that's why it has to be a straight line. If we could not write it in this form, such that we had L and y in this place and x in this place, then it would not be a straight line. But since we can do it, it's y equals mx plus c form. It is a straight line. Make sense?
Yes, sir.
That's how you used to prove that you can draw a straight line from a particular graph. You used to convert it to y equals mx plus c form, right? If you had to prove that a function can be converted to a straight line form, that's what you do. You convert it to y equals mx plus c. If it can be written in y equals mx plus c form, that means it is a straight line. Okay. Yes, Mustafa, this is linear law. This is from the topic logs and linear law. This is the standard question on linear law. Just convert it to y equals mx plus c form, find the gradient and the y-intercept, and use that to find any unknowns that you have. Okay, that was question number 3. Now we have complex numbers again. We have done loci earlier already in question number 2. Now this question has something else. It says complex number u is defined by u equals 3 plus 2 iota divided by a minus 5 iota, where a is real. Express u in the Cartesian form x plus iota y, where x and y are in terms of a. Okay, now it's a fraction. One complex number is being divided by another complex number. How do you simplify complex numbers like this? You multiply and divide by conjugate, right? That's what you do. 3 plus 2 iota divided by a minus 5 iota. All you have to do is multiply and divide by the conjugate of this, multiply by a plus 5 iota, and also divide by a plus 5 iota. In the numerator, you have 3 plus 2 iota into a plus 5 iota. Let's multiply them and see what that gives you. 3 times a plus 3 into 15, 3 into 5i, that's 15 iota, plus 2a iota, plus 10 iota squared. That's what we get in the numerator. What about the denominator? This is a minus b into a plus b form. That becomes a square minus b square. So what can we write it as? We can say this is a squared minus 5 iota whole squared, right? A squared minus b squared. That's what we get from a plus b into a minus b. Now we simplify this further and see what that gives us. Now we might run out of space here, so we're going to do this on the side, so we can write it on the right side later on as well. Okay, now let's simplify this. 3a plus 15 iota plus 2a iota. That's what you have in the numerator. What about this? 10 iota squared. Iota squared is -1. So this could become minus 10, or you can write it like this first, 10 into -1. Okay. What about the denominator? You have a squared minus 5 iota whole squared. What does that become? 25 iota squared. And now simplify this further. In the numerator, write the real terms together and imaginary terms together. Now, whatever terms do not have any real part, any iota, they are real. The terms that have iota, they are imaginary. So write those two types of terms separately. So you can write 3a minus 10 separately. That's the real part. And the imaginary part, that is 15 iota plus 2a iota. Okay, now let's simplify the denominator as well. What do we have in the denominator? A squared minus 25 into iota squared. Iota squared is -1. We could write it as a squared plus 25. Or if you want to show this clearly, you can write it like this first. A squared minus 25 into -1. Okay. And now you want to write it in this form, x plus iota y form. Now, real part should be separated and the imaginary part should be separated. You should write this as two separate terms. Real part separate, imaginary part separate. Now, what's the real part? You can see the denominator is all real now. We have gotten rid of iota from the denominator. In the numerator, these two terms are real. These two terms are imaginary. So we would write the real part separate. We would say this is 3a minus 10 divided by a squared plus 25. That's what you have as the real part. And then we have the imaginary part, 15 iota plus 2a iota. Now this as well, you should write it as a single term, as in iota should be separated. What's the whole imaginary part? The imaginary part is 15 plus 2a. Take iota common. And then in the denominator, you have a squared plus 25. This whole thing is the imaginary part, this into iota. This is that complex number written in x plus iota y form, x plus y iota form. All right, we've simplified this. All we did was multiplied and divided by the conjugate of the denominator and simplified it like this, and wrote the real part and the imaginary part separate. Now it says, given that argument of u is pi over 4, find the value of a. Okay, now what's u? This is u, what we found here. It says the argument of u is pi over 4, find the value of a. Now, if the argument is pi over 4, what does that tell us about this complex number? Where exactly is it going to be? which quadrant is it going to be in? Let's think about that. Pi over 4, that's 45 degrees. So if you had an Argand diagram, this point would be in the first quadrant. Okay, it's going to be in the first quadrant here. Pi over 4, that's 45 degrees. It's going to be here. Now it's 45 degrees. That means it's exactly in the middle of these two axes. This is imaginary axis, and this is the real axis. The total angle between the axes is 90 degrees or pi over 2 radians. Since this angle is pi over 4, it's exactly half of that. And we just talked about this in the previous example as well, when we drew a locus earlier. The angle there was also pi over 4. Remember what we talked about? When the angle is pi over 4, whatever distance you travel horizontally, it should be the same distance that you travel vertically. Whatever is the distance traveled in this direction, let's call this, let's say x, it should be the same distance that you travel in the other direction. Sorry, not in this direction, in this direction. Horizontally and vertically, when the angle is pi over 4, it should be the same distance, because it becomes an isosceles triangle like this with 90 here and pi over 4 here as well. So it's an isosceles triangle, two sides are going to be equal. So whatever distance you travel horizontally, it should be the same distance that you travel vertically. Now, why is that important? Because if the argument of this complex number u is pi over 4, what does that tell us? Whatever is the real part of this complex number, the imaginary part of the complex number should also be the same, right? Because whatever is the distance in this direction, it should be the same as the distance in this direction. So argument being pi over 4 means that the real part of this complex number and the imaginary part of this complex number, they are supposed to be the same. Okay, because we're traveling the same distance horizontally and vertically. So what we have to do is we have to equate these two parts since the argument is pi over 4. Okay, let's equate these two parts and see what we get from that. 3a minus 10 divided by a squared plus 25, that equals 15 plus 2a divided by a squared plus 25. Let's cross multiply. In fact, we could actually get rid of a squared plus 25. That's coming in the denominator for both of them. So this gets cancelled. The denominators, they get cancelled. How do they get cancelled? A squared plus 25 will go here, get multiplied, and then these two get cancelled. All right, so that's what happens. We can just get rid of this in this step already. What are we left with? We're left with 3a minus 10 equals 15 plus 2a, and that gives us a equal to 25. That's the value that we were looking for. A equals 25. Okay. All right, I hope that makes sense. Why are we equating? The angle is pi over 4. This angle is pi over 4. Since the angle is pi over 4, that means it's a 45-degree line, right? So whenever we have a triangle like this, it's a right angle triangle, right? If this angle is pi over 4, this is also pi over 4. Whatever is this side is also going to be the same, because it's an isosceles triangle. The angles that are equal, the sides opposite to those angles, they're also going to be equal. So the horizontal distance is the same as the vertical distance. So here, the horizontal distance represents the real part. Vertical distance represents the imaginary part. They are supposed to be equal to each other. We wrote the first line by equating these two. Basically, what we're doing is we're saying if argument of u is pi over 4, what that means is the real part of u is going to be the same as the imaginary part of u. That's all that we're doing. We're just equating the real part and the imaginary part. Okay, since the argument is pi over 4. Okay, I hope that makes sense. Let's move on. Question number 5. Now we have this trigonometric equation that we need to solve and find the value of tan x. So we don't need to find the value of x, we need to find tan x from this. Now, how can we do this? We've got different angles. This is x plus pi over 6, this is x minus pi over 6, this is x plus pi over 3, this is x minus pi over 3. So we would first have to use identities to expand this whole thing. Now, how do you do that? You have the identities in the formula sheet. Let me show that to you quickly. This is the formula sheet that you get. We are going to be using the compound angle identities for sine and cos. All right, these are this is what we're going to be using: sine of a plus b, sine of a minus b, cos of a plus b, cos of a minus b. Okay, that's what I'm going to be using there. When we use that here on sine of x plus pi over 6, sine of a plus b is sine a cos b, or plus cos a sine b. What I can do is I can just copy this in front of you, so then I can just do that quickly. Where was that? Yeah. Let me just copy these two here. These are what we're using. Okay. In the sine identity, when we have plus on the left side, in the sine identity, then when we have plus on the left side, we have plus on the right as well. In cos, when you have plus on the left, we have minus on the right. In sine, when we have negative on the left, we have negative on the right as well. In cos, when you have negative on the left, we have positive on the right. So keep that in mind and just apply these identities and see what you get. Sine of x plus pi over 6, what does that become? That's sine of a plus b. That becomes sine a into cos b plus cos a into sine b. That's the expansion of this first one. Now we subtract from this sine of x minus pi over 6. What does that become? That becomes sine of x into cos of pi over 6 minus cos of x into sine of pi over 6. That's the expansion of the sine terms. Let's do the same on the other side to the cos terms and see what that gives us. That equals cos of x plus pi over 3. That's cos of a plus b. That's going to be cos a cos b minus sine a sine b. So it becomes cos of x into cos of pi over 3 minus sine of x into sine of pi over 3. Okay, if you're running out of space here, what you can also do is you can write the part on the right side in the next mark. Okay, in the next line, sorry. So in the exam, I think you would definitely run out of space for this one if you write slightly bigger. In that case, you just continue with it in the next line like this, and that's okay. So this is cos x cos pi over 3 minus sine x sine pi over 3 for the first one. Subtract from this cos of x into cos of pi over 3 plus sine of x into sine of pi over 3. Okay, now that we've done these expansions, now let's simplify them. You see there's a minus sign in between. What happens is this whole term and this whole term, they get cancelled. And similarly, this whole term and this whole term, they also get cancelled on the right side. Now, what are we left with on the left side? Cos x into sine pi over 6 minus cos x into sine pi over 6. What does that become? Cos x sine pi over 6 plus cos x sine pi over 6. So on the left side, you're going to be left with 2 sine x into cos pi over 6. That's what you have on the left side. No, I'm sorry. What have I written here? I've copied something else. 2 into cos x into sine of pi over 6. That's what you have on the left side. On the right side now, you have this minus sine x sine pi over 3. And then you have minus sine x sine pi over 3. So on the right side, you have minus 2 into sine x into sine of pi over 3. That's what you get. Okay. And now sine pi over 6 and cos pi and sine pi over 6 and sine pi over 3, they can be evaluated from the calculator, right? Sine pi over 6, what's that? Sine pi over 6 is sine 30, that's 1 over 2. So it's going to be 2 cos x into 1 over 2, that equals minus 2 into sine x into sine pi over 3, which if you just input this in your calculator, you would get under root 3 over 2 for that. You need exact result. So don't write decimals. This is what we get. Now 2 and 2 get cancelled. And on the right side as well, 2 and 2 get cancelled. What are we left with? Cos of x equals minus under root 3 into sine x. Now bring cos x to the right side. Remember, what are we looking for? We're looking for the value of tan x. So cos comes to the right, so that's we get sine x over cos x. Under root 3 goes to the other side and have minus 1 over under root 3. Tan x turns out to be minus 1 over under root 3, and that's your final result. You could also write it in another form. This could also be written as minus under root 3 over 3. That's the rationalized form. So basically, we generally prefer not writing square roots in the denominator. So if you were to just put this in your calculator, minus 1 over under root 3, put this thing on your calculator will give you under root 3 over 3. So if you wanted, you could also write it like this, but it's not necessary. This is also fine. This is also fine. So tan x is either equal to minus 1 over under root 3 or minus under root 3 over 3. Both of them are going to be acceptable. Okay. If you put this in your calculator, so your calculator will give you this result, and that's perfectly okay. You could leave it like that as well. That's acceptable. Okay. All right. So that's part 1 here, part A of question number 5. Makes sense? Let's move on to the next one. Part B. Now it says, hence find the exact roots of this equation. Now let's see if there's any difference between this equation and the previous one. Sine of x plus pi over 6 minus sine of x minus pi over 6 equals cos. Okay, so it's exactly the same equation. It's the same equation as before. So that means after simplifying all of that, we have gotten this thing already. Tan of x equals minus 1 over under root 3. So we could use that result directly. We could say tan x equals minus 1 over under root 3 and take it from here. Find the values of x inside this interval. Now, how do you do that? You find the basic angle first of all. You could say tan of alpha. So replace x with alpha. On the right side, you make the number positive. So it becomes 1 over under root 3. Take inverse of this, tan inverse of 1 over under root 3. What do you get from that? Make sure your calculator is in radian mode. In general, in paper 3, Mustafa, always use radians, unless a question specifically uses degrees. And you would understand that because they would have a degrees sign there if they have used degrees. Otherwise, in paper 3, and in fact, in paper 1 as well, in general, you use radians, unless a question specifically uses degrees. And whenever you have something in terms of pi, that's an indication that it's an angle in radians, because angles are only written in terms of pi when they are in radians. Okay. In general, you should always use radians, unless a question specifies otherwise. Okay, so what's the basic angle? The basic angle turns out to be pi over 6. Alpha is pi over 6. And now you have to think of quadrants. Tan is negative, remember. Where is tan negative? Tan is negative in the second quadrant or in the fourth quadrant. So you could either be here or you could be here. Basic angle could either be this or this. Now, since the interval is from 0 to 2 pi, you have to look at positive angles in one full cycle. So the first angle that you get is this one, and then the next one is going to be this one. You can write down the answers. You can say one answer for x is pi minus pi over 6 in the second quadrant, and then 2 pi minus pi over 6 in the fourth quadrant. One of them turns out to be 5 pi over 6, and the other one turns out to be 11 pi over 6. These are the values of x that you get. Okay, these are the solutions to this equation. Make sense? Any problems? Good. Let's have a look at the next one now. Question number 6. It says the parametric equations of a curve are x equals under root t plus 3 and y equals ln t for t greater than 0. Obtain a simplified expression for dy over dx in terms of t. Okay, so we have to find derivative. These are parametric equations. We have to use chain rule for this, remember? So what do? We differentiate each of these two functions separately, each of these two equations separately. From the first one, we get dx over dt. Now, for that, you first have to write it in power form. So you can use the power rule. It can be written as t raised to power 1 over 2 plus 3. And that's what the function x is. Now, apply power rule on this, t raised to power 1 over 2. What's the derivative of this? You multiply by the power. So it's 1 over 2 times t. Subtract 1 from the power. So it becomes t raised to power minus 1 over 2. What's the derivative of 3? It's 0. So that's dx over dt. Okay, now what about dy over dt? Derivative of ln t. Remember, derivative of ln x is 1 over x. They've just replaced x with t here. Derivative of ln t with respect to t is 1 over t. All right, that's the second derivative. Now we want dy over dx. So for that, we have to use chain rule. How does chain rule work? If dy over dx is the subject, we're going to have two fractions. In the first fraction, this is going to be the numerator, dy, and in the second fraction, this is going to be the denominator, that's dx. And in the remaining places here and here, you would have the third variable, which is t. So you have dt here and dt here. And that's going to give you dy over dx. Now, what's dy over dt? Dy over dt is 1 over t. We put that here. It's 1 over t multiplied by dt over dx. You have found dx over dt. What's going to be dt over dx? Reciprocal of this thing. Now, what's the reciprocal of this thing? Just switch the numerator and denominator. It might become easier to think of it like this, that you first write it in this form. Make the power positive by taking it to the denominator. Dx over dt is 1 over 2 t raised to power 1 over 2. And now when you take reciprocal of this to make it dt over dx, what would that be? This just goes to the numerator, and that becomes 2t raised to power 1 over 2. And that gives us 2t raised to power 1 over 2 minus 1, which is minus 1 over 2. You could leave it like this, and that's perfectly okay. Or if you wanted, you could write it like this, 2 over t raised to power 1 over 2 or under root t, however you want to write that. Okay, that's dy over dx. Make sense? That's the first part. Now it says, hence find the exact values, exact coordinates of the point on the curve at which the gradient of the normal to the curve is minus 2. Okay, now what does that mean? Think about it. You have a curve. Let's say that looks like this. You have a point here somewhere at which the normal has a gradient of minus 2. This gradient is minus 2. Normal is perpendicular to the curve at that point. If the gradient of the normal is minus 2, what about the gradient of the curve or the tangent at this point? It would be negative reciprocal of that, right? Change the sign, take reciprocal. This gradient would be 1 over 2. So what that means is, this point that they're talking about, at this point, it's this point here, the gradient of the curve is 1 over 2. Okay, so all you have to do is put the gradient of the curve. What's the gradient of the curve? Gradient of a curve is given by its derivative. So we have found the derivative already. Put the derivative equal to 1 over 2. And that will give you a value for t. And we'll see what to do with that. After that, dy over dx is supposed to be 1 over 2, right? Because that's the gradient of the curve at that point. And that gives you 2 over t raised to power 1 over 2 equal to 1 over 2. Right? Yeah, so that's what we have. Cross multiply, and that will give you 4 equals t raised to power 1 over 2. Now you take square root. When you take square root, sorry, not square root, you have to square both sides to get rid of this power 1 over 2. And that will give you t equal to 16. Now they were looking for the exact coordinates of the point. Coordinates means the values of x and y. You have found the value of t at that point. Now you know that x equals this and y equals this. You can use that to find the values of x and y. x equals under root t plus 3 and y equals ln of t. Just input this value of t inside these two functions and see what you get. X equals under root of 16 plus 3, that gives you 4 plus 3, which is 7. The value of x turns out to be 7. And y equals ln of 16. They wanted an exact answer, so you just leave it like this. Don't write it in decimals. This is the final result that you get. Now, what's the point that they were talking about? 7 and ln of 16. That's your final answer. Is that okay? Now, there is a confusion that some of you might have about under root of t here. I'm not sure if somebody has it right now or not, but I'll just explain it because otherwise you might get confused later on. We are not going to put plus minus here. It's just going to be positive. It's not going to be plus minus. Because we already have under root t, under root written there. So basically, when you have something like this, for instance, when you have x squared equals 16, for instance, if you had something like this, x squared equals 16, and then you take square root yourself, what you do is you put plus minus like this. You say x equals plus minus under root 16. And then you break it down into two parts. You can say x equals under root 16 or x equals minus under root 16. And then one value turns out to be 4 and the other value turns out to be minus 4. Whenever you take square root yourself, you have to put plus minus like that. But if the square root is already there, and they do not have plus minus outside, like in this case, they do not have plus minus outside. What that means is, it's actually the case, I'm sorry. What that means is it's actually the case where you have plus sign, because if there's nothing outside, that means there's plus. So it's basically, it's this case and not this case. If it was the negative case, they would have written negative outside explicitly. Since they have not written plus minus there or any of the signs, we say that this is actually going to be plus. So whenever the square root is already there, just use the sign that they have there. In this case, it's positive. You leave it as positive. You don't put plus minus. When you take square root yourself, in that case, you have to put plus minus. Okay, because then it becomes under root 16 or minus under root 16. In this case, they've only used this case with the plus sign. Okay, so that's what you need to keep in mind. All right, Mustafa, you need to be specific. What exactly do you not understand? Explaining again means doing the whole thing again. You have to be very specific. What exactly do you not understand? You can ask verbally, maybe. Okay, good. That's good. Part B. So that was the second part. Let's look at question number 7 now. Now it's a differential equation. The variables x and theta satisfy this differential equation. It's given that x equals 1 when theta equals 0. Solve the differential equation, obtaining an expression for x squared in terms of theta. Now, how do we solve differential equations? For solving differential equations, the first thing we have to do is we have to separate the variables. All right, so that's where we start from. We separate the variables. Dx is on the left side, so all the x terms should be on the left side. D theta is in the denominator. We'll have to take d theta to the right side and then integrate both sides separately. Okay, so how do you do this? Let's take d theta to the other side. We can take tan theta to the other side as well. And this whole thing, x squared plus 3, we can bring that down here in the denominator. So separating the variables would look like this. We could bring x squared plus 3 to the left side. With dx, d theta goes to the right side. And along with that goes tan theta. And we have tan theta into d theta on the right side. Okay, that's separation of the variables. Variables are separated. We have x terms on the left side, theta terms on the right side. Now we integrate both sides. Now, the question is, how do we integrate these sides now? Now, on the left side, we have a fraction. Now, for fractions, what rules do we have? We have the ln rule, tan inverse rule, partial fractions, polynomials where you do quotient plus remainder over divisor, splitting the numerator. You have a bunch of rules for fractions. You need to remember all of them, the conditions for all of them. Which rule applies in this case? You can see you have x squared plus 3 in the denominator. What's the derivative of x squared? It's 2x. You can have the derivative of the denominator in the numerator in this case. So this is the ln rule. This is the ln case where numerator can be written as the derivative of the denominator. You need to remember all of those different rules, right? For integrating fractions. That's very important. If you don't remember all of those rules, integration and differential equations, they're going to be very difficult. Okay, so make sure that you have all of those rules on your fingertips and their conditions. ln rule, tan inverse rule, partial fractions, quotient plus remainder over divisor that you do in case of improper fractions. Then sometimes you split the numerator. Then you have two other ln forms given in the formula sheet. So you need to remember all of those conditions. You can find them in the notes as well that you have in the WhatsApp group. In the integration section, you'll find that there, all of those different rules. So make sure that you remember all of those rules. So in this case, what's the derivative of the denominator? The derivative of the denominator is 2x. So in order to integrate this, we want 2x in the numerator. What we can do is we can say, let's put 2 here. And to balance that, divide by 2 outside. Now this is the ln form. And this can be integrated like this. 1 over 2 outside remains as it is. Integration of this thing is ln of the denominator. That's ln of x squared plus 3. That's the integration of the left side. What about tan? How is tan integrated? Again, you need to remember this. Integration of tan and cot, both of them are integrated using the ln rule as well. We write tan as sine over cos, right? So tan is going to be written as sine over cos. Sine theta over cos theta. And then we could try using the same rule, the same ln rule on this as well. How is that going to work? What's the derivative of cos? The derivative of cos is minus sine theta. So we need minus sine theta in the numerator for this to be the ln form. Do we have minus sine theta in the numerator? We don't. We have plus sine theta. What we can do is we can put minus inside, and to balance that, we put minus outside. And now this is the ln form. So the right side can be integrated like this. The minus sign outside remains as it is. It becomes minus ln of cos of theta, ln of the denominator. And then you put plus c here as well. You put plus c on any one of the two sides. Let's say we put that on the right side. This is how you integrate this. Okay, that's the integration of both sides. On both sides, we use the ln rule. Now, we have to find the value of c here. How do you find the value of c? You have to put these values of x and theta to find the value of c. Let's put those values here. You put x equal to 1 and theta equal to 0, and see what that gives you. 1 over 2 into ln of 1 squared plus 3, that equals minus ln of cos of 0 plus c. Now that gives you 1 over 2 into ln of 4. On the right side, you have minus ln of cos of 0. Cos of 0 is 1. So this is minus ln 1 plus c. ln 1 is 0. So the value of c turns out to be 1 over 2 times ln 4. Do not use decimals. In equations, you should not be using decimals anywhere. Okay, write this in exact form. So what does this equation become then? It becomes 1 over 2 into ln of x squared plus 3 equals minus ln of cos of theta plus 1 over 2 into ln of 4. Now, what do we want? They want x squared in terms of theta. So now it's a log question from this point onward, because you need to use the rules, the laws of logarithms to make x squared the subject somehow. Okay, we have x squared only on the left side. That's what we need to make the subject. Now we have to apply the multiplication rule or division rule or power rule of logs to make x squared the subject somehow, we have to get rid of this ln as well. How do you do that? You have ln on each of the terms. Every single term has ln in it. All right. Okay. Every single term has ln in it. What you should do is you should somehow get rid of ln. How can you do that? In order to apply multiplication or division rule, we need to get rid of these numbers outside. So we have 1/2 here. We have 1/2 here as well. How can we get rid of them? We can simplify this equation by multiplying the whole equation by 2 first of all, so it becomes ln of x squared plus 3 equal to minus 2 ln of cos theta plus ln of 4. What I've done is I've multiplied the whole equation by 2 to get rid of the fractions. Now, on the right side, Abdullah, we could take 1/2 to the power, but remember what we want to do is we want to make x squared the subject. So we would not want to complicate things here. We would want x squared separated, right? So we don't want a power over this. That's going to complicate things because we won't be able to make x squared the subject then. We'll have to take square at the end on both sides for that. So in order to avoid that, it's simpler to just multiply the whole equation by 2. Okay, so this becomes ln of x squared plus 3. On the other side, can we use the division law or the multiplication law somehow? We can't yet because we have 2 here. This 2, we'll have to take to the power first now. So it becomes minus ln of cos theta whole squared plus ln 4. Now we can apply the division law on the right side. We have plus here, we have minus here. We can use the division law. So it becomes, it might make it easier for you to understand. If we rearrange this, we can write it like this: ln 4 minus ln of cos theta whole squared, right? So this is subtraction outside. We can write it as a single term as 4 over cos square theta using the ln rule of, using the division law of logarithms, okay? And now since we have a single ln on both sides, we have a single ln term on both sides, we can get rid of the ln and we can say it's x squared plus 3 equal to 4 over cos square plus 4 over cos square theta, and then it becomes x squared equal to 4 over cos square theta minus 3, and that's what we wanted. That is x squared in terms of theta. Okay. Rukaya, you could put plus c on the left side as well, if that's perfectly okay. You have to put it on any one of the two sides. You could put that on the left. So instead of this, you could have instead of this, you could have c on the left side here. In that case, the value of c that you get would end up being minus 1/2 ln 4, and that's perfectly okay. That's the same thing. The final result is going to be the same in any case. Okay, the final result is going to be the same in any case. Okay, makes sense. No problems. Okay, good. Let's move on. Okay, now this is another question that is going to take time. So just a tip for the exam, now that we have this question, leave this question for the end. Never do it in the middle of the exam, the sketching part. It's going to waste time, and it's only going to be 2 marks generally, maximum 3 marks if at all, and it takes time. Do not touch this in the middle of the exam. Okay, now that does not mean that you leave this whole question. That's also something that you should never do because it's an iteration question. These are free marks, these 2 marks, and then this mark, and then these marks. Do not skip these parts. Skip the sketching part. Okay, leave that for the end of the exam because it takes time, and you can end up perhaps missing out on an easier question elsewhere in the paper because of this. Okay, so I'll do that for now as well. I'll leave it for the end because it's not really needed for the next parts as well. We just have to show that this equation has only one real root. Okay, so just know that it has one root and do the second, third, and fourth parts. Come to this part at the end if you have time. Okay, It's not that difficult, but it's only 2 marks. You can't afford losing marks on an easier question later on because of this. And since we have it in partial fractions binomial yet, most likely there'll be a question in partial and binomial somewhere as well. Yeah, so see, you have partial fraction question here, binomial question here. These are also easy marks. You can't afford spending too much time on that earlier question and end up losing marks in this. Okay, that's good to know, Mustafa. Thank you. Question number 8. This is iteration. This is iteration. The part B onward is iteration. The first part is basically sketching from the logs topic, but the rest of it is iteration. Okay, let's look at the second part now. Okay, so it says show by calculation that the root of that equation lies between 1 and 2. This is the equation, under root x equals e raised to power x minus 3. This is the equation. We need to show that the root of this equation lies between 1 and 2. Now, how do you do that? You have to convert the equation to this form, first of all. Take everything to one side and leave only 0 for the other side. Okay? That's the first thing you should do. Take everything to one side. So let's say I write it like this, under root x minus e raised to power x plus 3 equal to 0. So now it's that form. You would say this is your f of x. This is the function that is equal to 0. Okay. Now all you have to do is put x equal to 1 here and x equal to 2 here. If they have different signs, that means there's a root between these two values. So that's what you do. You put x equal to 1 and see what f of 1 turns out to be. That's square root of 1 minus e raised to power 1 plus 3. You can see what that is. Under root 1 minus e plus 3, that is 1.28. Now, the actual value does not matter. What matters is that it's a positive value, okay? And then you input x equal to 2 and see what that gives us. Under root 2 minus e raised to power 2 plus 3. Let's see what that is. Under root 2 minus e power 2 plus 3. That is minus 2.97. This is negative. One of them is positive, the other is negative. You are going to write down that the sign is changing. That is why a root exists between these two values. Writing that statement down is important. You get 1 mark for calculating these values, and then 1 mark for writing down that since f of 1 and f of 2 have different signs, or you can say since the sign is changing, the root lies between 1 and 2. Or you can write something similar in your own words. The important part is that the sign is changing. The sign is different. This sign is different. The sign is different. That is why a root lies between those two values. Okay. All right, let's move on. Part C. Now it says show that if a sequence of values given by this iterative formula converges. Converges means that it gives you a result. It gives you an answer. That's what it means. Then it converges to the root of the equation in A. Now, this is a complicated way of saying that show that this iterative formula corresponds to this equation. That this equation has this one possible iterative formula. That's what it means. That this iterative formula corresponds to that equation. So let me explain again. It says if a sequence of values given by the iterative formula converges, that means if this iterative formula was to give you an answer, that answer would be the root of the equation in part A. So that answer would be for this equation. Now, how do you prove that? That this equation is what this iterative formula is for. Let me write down that equation. That equation was under root x equals e raised to power x minus 3. And the iterative formula is this. Remove n plus 1 and n from this. What does that give you? That gives you x equals ln of 3 plus under root x. You just have to show that one of these forms can be converted to the other form. You can either go from this form to this form or from this form to this form. So you have to convert one form to the other to prove that they are actually the same. This iterative formula is coming from that equation. Okay. Now you can go in either direction, it doesn't matter. So let's start from this one and try to go to the other one. Or you could do it the other way around as well. Anyway, I think doing it the other way around might be easier. How do you get rid of this ln? The base of ln is e. Remember, e goes to the other side, becomes the base of x. So we could write it as e power x equal to 3 plus under root x. And now you could have under root x on one side and e raised to power x minus 3 on the other side. And these are both the same. That's what you had to do. That the iterative formula is coming from that equation. Is that okay? Or you could go the other way around as well and prove that this equation can be written in this form. Okay, that's just 1 mark. That's what you have to do here. Now you have this iterative formula. It says use this iterative formula. Xn plus 1 equals ln of 3 plus under root xn to calculate the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Now, how do you do this? You need a starting point. What's the starting point? They have not given you a starting value. However, you have proved already in the second part of this question that the root lies between 1 and 2. Now it's somewhere between 1 and 2. So you start from your best guess. You can say, so between 1 and 2, you start from the midpoint of those two values, right? So you say x1 is 1.5. That's what you generally use. Although even if you were to use another value between 1 and 2, 1.4, 1.6, 1.7, you would eventually get the correct result at the end. But generally in the marking schemes, they use the midpoint. So that's what you should do. Use the midpoint. Okay, start from that. And then you have to find x2, x3, x4, and so on. How is this going to work? In your calculator, you're going to input 1.5. Press the equal button. That will save 1.5 and the answer button on your calculator. Then you write down this function, replacing xn with answer. So you write this function on your calculator like this, ln of 3 plus under root of answer. You write this whole thing on your calculator and then just press the equal button. And that will give you x2. You press the equal button again, you get x3, x4, and so on. Let me do this. These are the easiest marks on this paper. Make sure that you understand this process very well. It's the same question repeated every time, sometimes 3 marks, sometimes 4 marks. So what do? Write 1.5, press the equal button. It saves 1.5 in the answer button of your calculator. Then put ln of 3 plus under root of answer. Brackets closed. Press equal, and I'm getting 1.44095888. Now they want the iterations to be correct to 4 decimal places. Now accuracy is really important here. The last decimal place should be properly rounded off. So this becomes 1.440959. Rounding off to 4 decimal places, what would this become? This would become 4410. So you have to round it off properly. Okay, that's x2. Now press the equal button again. You'll get the next value. That's giving me 1.43517. So that rounds off to 52. And then you have x4. Press the equal button again. 1.4346. Press it again. You get x5. You get 1.43454. So that's 45. Let's do one more. 1.4345. Now all decimals are stable already. So we're going to stop at this point. We want the final answer to be correct to 2 decimal places. Okay, so the final answer is therefore 1.43. Now let's see if they've called this root something. No. So sometimes they use a name for the root. They might call it alpha or something. In that case, it's necessary to write alpha equal to that. In this case, they haven't done that. So you just say x equals this, x equals 1.43. That's your final answer to do 2 decimal places. Okay. That's part D. All right, let's move on. Now we have this diagram that shows the curve y equals x e raised to power minus 1 over 4x squared for x greater than or equal to 0 and its maximum point M. Find the exact coordinates of the point M. Now it's a turning point. How do you find? Well, 1.5, basically, we had proved that the root lies between 1 and 2. We don't know what the actual solution is. We need some starting point. The starting point is calculated like this. We just find the midpoint of this, 1 and 2. We find the midpoint of 1 and 2, that's 1.5. So that we use that as the starting point. Okay, so we use 1.5 as the starting point because of that. It's the midpoint of 1 and 2. Okay, the diagram shows the curve y equals x e raised to power minus 1 over 4x squared for x greater than or equal to 0. And its maximum point M. Find the exact coordinates of the point M. Now, it's a turning point. How do you find turning points? You find the derivative for that equal to 0. Now, this is a product. How do you differentiate products? You have to use the product rule. What does the product rule look like? Differentiation of u into v is uv dash plus vu dash, right? So we can say this thing is u, and this is v dash. This is v, sorry. What does that give us? dy over dx. That equals u as it is, that's x, into derivative of e raised to power minus 1 over 4x squared. What would that be? E power something, the derivative of that is the same. E power that thing, e raised to power 1 minus 1 over 4 times x squared. But then you have to multiply by the derivative of this thing, derivative of the power. What's the derivative of minus 1 over 4 times x squared? Multiply by 2, that's minus 1 over 2 times x. Minus 1 over 2 times x. You multiply by the derivative of this power. Okay? That turns out to be minus 2 over 4 into x power 1. That simplifies to minus 1 over 2 times x. I hope that makes sense. That's uv dash plus v as it is. So now e raised to power minus 1 over 4x squared as it is, multiplied by u dash, the derivative of x, which is just 1. That's your differentiation. Okay, so we have differentiated this function. Now, since we're looking for the turning point, we put this derivative equal to 0 and see what that gives us. 0 equals minus 1 over 2 x into x, that is x squared, into e raised to power minus 1 over 4x squared. Or in fact, I think what we should do is we should take e power minus 1 over 4x squared common. Yeah, so that's how you would have to solve it. Rather than multiplying it inside and complicated things, you have e power minus 1 over 4x squared in both the terms. You can take that common. What does that leave you with? E power minus 1 over 4x squared. Take that common. Inside you're left with minus 1 over 2x into x. That's minus 1 over 2x squared plus 1. Now it's a product. Two things are multiplying and the result is equal to 0. That means either the first thing is equal to 0 or the second thing is equal to 0. So we say either e raised to power minus 1 over 4x squared equals 0 or minus 1 over 2x squared plus 1, this equals 0. Now, this is not going to give you any result. You can try. How would you try to solve this? Taking log. If you take log, you get stuck because on the right side, you get ln 0. That's not possible. So you don't get anything from the first equation. Why? Because e power something can never be equal to 0. All right. E is a positive number. You can not raise that to any power and get 0 as the result. So this is not possible. From the second equation, we get 1 equals 1 over 2x squared, x squared equals 2, and the value of x turns out to be plus minus under root 2. Okay. However, if you look at the graph, M is on the right side here. That means the x coordinate of m is supposed to be positive. So we don't use negative, we only use the positive result. If we say x is supposed to be equal to under root 2. Okay, so we only use the positive result. So the value of x turns out to be under root of 2. We need to find the exact coordinates. That means we also need the y coordinate. How do you find the y coordinate? Put this back in the original equation and you'll get the corresponding y coordinate. Y equals x e raised to power minus 1 over 4x squared. Let's put that value of x here. It becomes under root 2 into e raised to power minus 1 over 4 into under root 2 whole squared. And that will give you under root 2 e raised to power minus 2 over 4, which is minus 1 over 2. That's the value of y that we get. So the coordinates of m therefore are under root 2 and under root 2 e raised to power minus 1 over 2. If you wanted, you could write e power 1 over 2 in the denominator, and that's also okay. We did not choose negative because on the graph you can see m is here. So the x coordinate is supposed to be positive. We are finding the x coordinate of m, so it has to be positive. So we only use the positive result. Okay. All right, so that was part A. Now it says using the substitution, x equals under root u or otherwise. Now, whenever they say or otherwise, that's generally a challenge for you that you can try anything else if it works for you. Generally, it doesn't. So don't bother with that. Just use what they have asked you to do. Use the substitution x equals under root u. Find by integration the exact area of the shaded region bounded by the curve, the x-axis in the line x equals 3. So we need to find the area of the shaded region. Now, it's area between graph and x-axis, right? Limits are from 0 to 3. We just have to use the formula, the area formula that looks like this. Integration of y with respect to x, limits are going to be from 0 to 3 in this case. Okay, now what's y? Y is this. Let me write that here. Y equals x e raised to power minus 1 over 2x squared. Sorry, 1 over 4x squared. That is y. We just use that formula. Area between a graph and x-axis, that's integration of y, which is x e raised to a power minus 1 over 4x squared with limits 0 to 3. We have to integrate it with respect to x and put these limits, and that's going to give us this area. Now we have to use a substitution here. This is the substitution that's given, x equals under root u. Now, how do you use a substitution like this? Let's write it on the side. The first thing you always have to do is differentiate it because we want to convert dx to du as well. For that, you have to find the derivative of this. X equals under root u. That means x equals u raised to power 1 over 2. What's the derivative of this? Dx over du. That's going to be 1 over 2 into u raised to power minus 1 over 2. Okay. And you could write it as 1 over 2 u raised to power 1 over 2 in the denominator like this. That's dx over du. Now, when we do the substitution, we actually want to get rid of this dx from this. So what we do is we make dx the subject. We have du in the denominator, dx in the numerator. We want to make dx the subject. That will give us dx equal to du over 2u raised to power 1 over 2. Okay, now we'll think about the limits as well, but for now, let's just do the substitution. We'll consider the limits in a few minutes. Let's apply this substitution here first of all. So what do you have to do? In place of x, you're going to put this. And in place of dx, you're going to put this. These are the only two substitutions that you are going to do in the beginning. And then we will see what to do after that. In place of x, you have u raised to power 1 over 2. So it becomes u raised to power 1 over 2. Leave everything else as it is. In fact, this is also something that you can change already. So let's do that. E raised to power minus 1 over 4. If x is u raised to power 1 over 2, what about x squared? X squared is u. Right? So in place of x squared, you have u here, minus 1 over 4 times u. And then you have dx. What is dx converted to? In place of dx, you have to put du over 2u raised to power 1 over 2. And everything is converted to u now. All right. Now, you can see there's some cancellation happening here. U raised to power 1 over 2 and u raised to power 1 over 2, they get cancelled. And we're left with 1 over 2, you could write this 2 outside. This is just a constant, so it's okay to write it outside if you want. 1 over 2 into integration of e raised to power minus 1 over 4 times u du. Okay, that's what we get. Okay, so we have done the substitution. Now, what we also have to do is we have to change the limits. Let's change the limits as well. Now, let's write both of them separately. We have an upper limit, we have a lower limit. Clearly write here what the upper limit is and what the lower limit is. That's very important, because sometimes the smaller number ends up being the upper limit and the larger number ends up being the lower limit. So you'll get confused. Clearly write what the upper limit is and what the lower limit is. The upper limit in this case is 3. So that's x equal to 3. That was the upper limit. The lower limit was x equal to 0. Now, what's the substitution that we're using? X equals u raised to power 1 over 2. So it becomes 3 equals u raised to power 1 over 2, or 0 equals u raised to power 1 over 2. Right? So in place of x, we input 3 ones and then we input 0 ones. What are the corresponding values of u that we get? U equals 9 or u equals 0. So the limits for u are going to be 0 to 9. So the limits are going to be changed to 0 and 9 here. Okay? When you do the substitution. Now you just have to integrate it, input the limits. You have 1 over 2 outside as it is. What's the integration of this? E power something remains e power that when integrated. So it remains e raised to power minus 1 over 4 times u. However, you have to divide by the derivative of this thing. What's the derivative of minus 1 over 4 times u? U is like x here, right? U is the variable. Derivative of minus 1 over 2 times u is minus 1 over 2. Sorry, minus 1 over 4 times u is minus 1 over 4. So you divide by minus 1 over 4. And the limits are from 0 to 9. Now let's simplify this. This 4 can go to the numerator and become minus 4 e raised to power minus 1 over 4 times u. Outside, you've got 1 over 2. Limits are from 0 to 9. Now again, this is a constant, just multiplying. You could make things simpler by writing it outside. Minus 4 over 2 like this. Inside, you're left with e raised to power minus 1 over 4 times u from 0 to 9. Now, input the limits. Outside, you're left with minus 2. Minus 4 over 2 is minus 2, right? Now, when you input the limits, you input 9 once, and that gives you minus 9 over 4 times u. Subtract from that, e raised to power 0, right? 0 over 4, that's 0. You want an exact answer? Yeah, exact area. What does this become? Minus 2 into e raised to power. I'm sorry, what am I doing? When you input 9, u gets eliminated as well. E raised to power minus 9 over 4 minus e raised to power 0. So you have minus 2 into e raised to power minus 9 over 4 minus e raised to power 0, which is 1. And that gives you minus 2 e raised to power minus 9 over 4 plus 2. That's the area of this shaded region that we were looking for. Okay, 2 minus 2 e raised to power minus 9 over 4. Is that okay? Make sense? This is the exact area. Okay, let's move on. Question number 10. For volume, you have that other formula, pi y squared integration of x. If it's with x-axis, with y-axis, you have pi x squared y. So you have to find square first and then integrate. Okay, next we have partial fractions and binomial. Let's actually complete the paper. Hopefully we can do this. How long is this one? Okay, let's try to be quick now. These are partial fractions. First of all, you have to figure out whether the partial fractions are proper or improper. In this case, it's a proper fraction. 1 is the degree in the numerator, and the denominator, the degree is 3. So what is the form of these partial fractions? 24x plus 13 divided by 1 minus 2x multiplied by 2 plus x whole squared. What does that give us? You have non-repeated linear factor, that's a over 1 minus 2x. And then you have a repeated linear factor that becomes b over 2 plus x plus c over 2 plus x whole squared, right? That's the form that we get for this. For repeated linear factor, we have two separate fractions like this. Now, this is the form that we have. Now, multiply this denominator on the right side, yes, Faizan?
Sir, there is another form for 2 plus x whole square, bx plus c. Is it better to write in that form, or this one is
No,
better?
you can't use that for this one. That is when you have a quadratic factor in the numerator, in the denominator. This is repeated linear factor.
Oh, okay.
That's for quadratic factor. That's when you have x squared inside the bracket. Okay,
I
you
saw
can't
it
use that
in
here.
marking scheme, so I thought that was correct.
Sometimes they allow that, but this is the form that they prefer. Sometimes they do allow that other form as well, but they can deduct 1 mark for that because that's not the standard form that they expect from this. Okay, so this is the one that you should prefer.
Okay, sir.
Okay, now let's multiply this denominator on the right side and see what that gives you. 24x plus 13. Now, when this denominator gets multiplied with the first fraction, 1 minus 2x gets cancelled, and you're left with a into 2 plus x whole squared. And then with the second fraction, you have 2 plus x here. When you multiply by 1 minus 2x into 2 plus x whole squared, 1 power of 2 plus x, that gets cancelled. And we are just left with 1 power of 2 plus x. So that's 1 minus 2x into 2 plus x like this. And then we have c into 1 minus 2x. Okay, that's what we get. Now we put some values of x to make this simpler. Yes, Fardeen, that's correct. But in your syllabus, you would only have that case when the power in the numerator is equal to the power in the denominator for improper fractions. In partial fractions, it will only be equal. But yes, when it's greater than, that's also is an improper fraction. That's correct. Okay, anyway, let's get back to this. So what you do is you put some values of x. You can make this bracket 0. How do you do that? You can put x equals minus 2 to make this bracket 0. What that does is that leaves you with 24 into minus 2 plus 13. On the other side, you have a, which is whatever that is. You have 2 plus x whole squared. When you input x equals minus 2, this term gets eliminated. You have 2 plus x here as well. This term will also get eliminated. And the last term, you have c into 1 minus 2 into minus 2. And that's going to give you the result. 24 into minus 2 plus 13. What's that? Minus 48 plus 13. That is minus 35. On the other side, you have 1 plus 4, which is 5. 5 times c. So the value of c turns out to be minus 7. Okay, that's what the value of c turns out to be. Now you think of another fraction that you can make 0. 1 minus 2x, how can you make this equal to 0? You could put, for this, you could put x equal to 1 over 2. You can try putting that equal to 0. 1 minus 2x equal to 0. What does that give you? X equals 1 over 2. So that's the next value of x that you can input. You can input x equals 1 over 2. On the left side, you get 24 into 1 over 2 plus 13. On the right side, you have a into 2 plus 1 over 2 whole squared. This term has 1 minus 2x. That's going to become 0. The last term also has 1 minus 2x. That's also going to become 0. You can try by inputting values that they are going to become 0. What are we left with? 12 plus 13. That's 25. That equals 5 over 2 whole squared. That's 25 over 4 times a. And the value of a turns out to be 4 from this. Okay, so we've got the values of c and a. What are we left with? B. Do we have any other bracket that we can make 0? No. We're done with 2 plus x. We're done with 1 minus 2x. We don't have any other brackets that we can make 0. What we do in this case is we just put another bracket, put x equal to 0 now. We could input x equal to 0 now and see what that gives us. Put x equal to 0. That's a simple value to use. On the left side, you have 0 plus 13 when you input x equal to 0. On the right side, you have a. Now you can input the values of a and c, which we have found already. A is 4 into 2 plus 0 whole squared plus b is what you have to find out into 1 minus 0 into 2 plus 0. And then the value of c is minus 7. So minus 7 into 1 minus 0. You could simplify all of this to find the value of b. 13 equals 4 into 2 squared. That's 4 into 4. That's 16. Plus b into 2. That's 2 times b minus 7. And the value of b turns out to be 20 minus 16 divided by 2. That's 4. The value of b turns out to be 2. Right? So we have the values of a, b, and c. That's what we were looking for. So the partial fractions therefore become these are the partial fractions that we get. A is 4, b is 2, c is minus 7. So these are the final partial fractions that we got. Okay, that's the final result that we have. All good. Let's look at the next part now. Now it's expansion of f of x. Now you've already found the partial fractions form. So you should be using that partial fraction form now. That's 4 over 1 minus 2x, 2 over 2 plus x, and 7 over 2 plus x whole squared. Let's bring all the denominators to the numerator and see what that gives you. You have 4 into 1 minus 2x power minus 1 plus 2 into 2 plus x power minus 1 minus 7 into 2 plus x power minus 2. So bring everything to the numerator like this. All right. Is that copied correctly? Yeah. So this is what we have. Now, in order to use the binomial formula, remember that binomial formula, it's written in the formula sheet. It looks like this: 1 plus x whole raised to power n. That is equal to 1 plus nx plus n into n minus 1 divided by 2 factorial into x squared, and so on. You have to expand up to x squared. So this is all that we need. Now, for using this formula, remember the first term has to be 1. Now, in the first case, it is already 1, so that's all right. In the second and third case, it's not 1. So what you have to do is you have to take 2 common outside to make the first term 1 first of all. So it becomes 2 into you have 2 outside, you take 2 common. So 2 into 2 raised to power minus 1. So you take 2 common outside. What are we left with inside? 1 plus x over 2 whole power minus 1. Okay, when you take 2 common outside, 2 is also going to have that power negative 1. Okay, and similarly, in the last term as well, you have minus 7. When you take 2 common outside, it's going to have power minus 2 over it. So 2 raised to power minus 2, and what are we left with inside? 1 plus x over 2 whole raised to power minus 2. This is what we get. Okay, what do we do now? Let's simplify this a bit first. So it's 4 into 1 minus 2x whole power minus 1. 2 into 2 raised to power minus 1. That's 2 over 2. They're going to get cancelled. And we're left with 1 plus x over 2 power minus 1 here. And then we have 7 into 2 raised to power minus 2. That becomes 7 over 2 squared, which is 7 over 4. Inside, you're left with 1 plus x over 2 whole raised to power negative 2. Okay. Now that you've, oops, I'm sorry, just give me a minute. I almost broke my pencil. Hopefully it's still working. Okay. Okay, so this is what we have. We have made the first terms 1 for all of them. All right. Now, you will expand each one of them separately, do this separately, This is the first expansion. Okay, those of you who are in the M1 group, can you please post in that group that our class is going to start in about 15 minutes. Is anyone doing that? We'll start in 15 minutes. What I'm going to do is, actually the problem is some people in that class have another class starting around 8:15, 8:30. So we want to finish that that M1 class by around 8:15, 8:30. We would want to do that. So because of that, this question number 11, we will leave this for the second part of this class that we will have around 9 o'clock today. Okay, 9:15. So those of you who are interested, you can attend at that point. Okay. Those of you who are interested, you can attend at that point. Otherwise, you'll have the recording available as well for that last question as well. Okay. So the last question number 11, I'm going to leave that for the second part of this class that we would have at 9 o'clock. Okay. 9 or 9:15, depending on when the M1 class finishes. Hopefully it finishes earlier, so we'll be doing that at 9 o'clock. That's okay with everyone. Okay. I'll be posting the recording anyway. So if you miss that part, it'll just be like 20-25 minutes in which we just complete that question and the graph question that we left earlier. We would complete that and then I'll post that recording. If you want to attend that, that'll be around 9 p.m. Okay, in which we'll do the last question. Let's quickly complete this one and then we end for today. This is the first part that we need to expand. This is the second part. Let's call this number 2. And we have this third part. Let's call this number 3. Now, what's the first expansion? 4 into 1 minus 2x whole power minus 1. Let's do this first expansion first. Let's apply the binomial formula on this and see what that gives us. Now, I would recommend picking this whole thing up as it is. Okay, that will make things easier when we combine everything again. So 4 into 1 minus 2x. Look at the formula. In place of x, we've got minus 2x. Okay, so what does it become? 1 plus n, which is minus 1 here, into x. In place of x, we've got minus 2x, plus n into n minus 1. So that becomes minus 1 into minus 2, divided by 2 factorial. That's just 2, into x squared. In place of x, we've got minus 2x, so minus x minus 2x whole squared. We only want to expand up to x squared. So we're going to stop at this point. And that's it. Now let's try simplifying this and see what that gives us. It's 4 outside as it is. Inside we have 1 plus 2x. Put this whole thing in your calculator. In place of x, put 1. You can put this whole thing in your calculator if you can't do it mentally. This is very straightforward, but sometimes you get something more complicated. You can put that whole thing in the calculator directly. Okay. In this case, this is just going to be plus 4x squared. Now you multiply 4 inside and see what that gives you. This is 4 plus 8x plus 16x squared. This is our first expansion. Okay. Then we do the second expansion and see what that turns out to be. Second expansion. You have 1 outside, that's multiplying. Inside, you have 1 plus x over 2 whole raised to the power minus 1. Let's expand this one now. In place of x, you've got x over 2. All right. Let's input this in the formula again. 1 plus n times x. What does that become? 1 plus n, which is minus 1 into x. In place of x, we've got x over 2. Plus n into n minus 1. That's minus 1 into minus 2 divided by 2 factorial. Into x squared, that means x over 2 whole squared. And that's it. We only need to expand it up to x squared. We stop at this point, simplify this, and this gives us 1 minus 1 over 2 times x plus 1 over 4 times x squared. That's the second expansion. Then you do the third expansion and see what that gives you. Number 3, that is going to be minus 7 over 4 multiplied by 1 plus x over 2 whole raised to power minus 2. Now, minus 7 over 4 outside remains as it is. And then you say 1 plus n, which is minus 2, into x, which is x over 2. Plus n into n minus 1, that's minus 2 into minus 3 divided by 2 into x over 2 whole squared. Now simplify this and see what this gives you. Minus 7 over 4 multiplied by 1 minus x. Put this whole thing on your calculator. In place of x, put 1. You will get the coefficient of x squared. Okay, let's see what that gives you. You have minus and minus outside. That's going to be positive 3 over 4. So that's going to be 3 over 4 plus 3 over 4 x squared. And this will give you, when it's simplified, minus 7 over 4 plus 7 over 4x minus 21 over 16 x squared. Is that okay? If there's a careless error, please do let me know. This is what we are getting. Okay. These are the 3 expansions that we have done. All right. Now we just have to add them up. Now, there's a reason why I took negative along here, because now at the end, it's going to be easy to just add all of these terms up. So if you run out of space, you can do this at the end and on the additional page. I'm going to do it on the side. We have those 3 expansions. Number 1 is 4 plus 8x plus 16x squared. Number 2 is 1 minus 1 over 2x plus 1 over 4x squared. And number 3 is minus 7 over 4 plus 7 over 4x minus 21 over 16 x squared. Can somebody tell me what those terms are to be when you add them up together? What's the first term? What's the second term? What's the third term? Anyone? Four plus 1 minus 7 over 4. That's 13 over 4. 8 minus 1 over 2 plus 7 over 4. That's 37 over 4. And then 16 plus 1 over 4 minus 21 over 16. 16 plus 1 over 4 minus 21 divided by 16. That's 239 over 16. X squared. That is the final result that we get. That's the final expansion. Okay. Now it says state the set of values of x for which the expansion in B is valid. Now remember the condition that we've got for this. It's written in the formula sheet like this. If you have 1 plus x whole raised to power n, the condition is modulus of x is less than 1. You could write that as x between minus 1 and 1. So in order for this expansion to be valid, this is the condition that we have. If you have 1 plus x whole raised to power n, x needs to be between minus 1 and plus 1. But if you have something else, if you have 1 plus x whole raised to power, in place of, I'm sorry, where is that? Should the set of values of x for which the expansion in B is valid? Okay, so now that is interesting because we've got 3 different expansions here. We have one expansion that has minus 2x. We have one expansion that has x over 2 and x over 2. Okay, now there are 2 different kinds of terms that we're getting here. We've got 2x and x over 2. So we have to consider both of them. One is 1 plus 2x. 1 minus 2x, sorry. Power minus 1. In this case, we say 2x has to be between minus 1 and 1. What does that give us? That gives us x between minus 1 over 2 and 1 over 2. What about the second one? This is the second expansion, 1 plus x over 2. You have to consider that as well. 1 plus x over 2. Now, both of them have x over 2 inside. This is the one that you're going to be using. With -1 or -2, inside you have x over 2 here. This gives you x over 2 between -1 and +1. What does that give you? That gives you x greater than -2 and less than 2. Now, these are two results that we're getting. One expansion is valid when x is between -1 over 2 and +1 over 2, and the other expansion is valid, other two expansions are valid when x is between -2 and 2. When are all of them valid? Right? All of them have to be valid at the same time for this expansion to be correct. You look at what is the intersection between them. What's the common part between them? What values of x satisfy both of these conditions? If you had x equals 1, for instance, that would not satisfy the first condition. So for both conditions to satisfy, you take the part that is common between both of them, and the final result from this is going to be x between -1 over 2 and +1 over 2. Because that's the part that is common between them. If you draw it in a number line, this is -1 over 2, this is 1 over 2, this is -2, this is +2. One is valid for this part, and the other is valid for only this part. For this part, therefore, both are valid. So that's our final result. We say x is supposed to be between -1 over 2 and +1 over 2. These are the values of x for which this expansion is going to be valid. Does that make sense to everyone? Is that okay?
Sir, we don't use the values multiplying outside the bracket.
No, that doesn't matter. It's only the inside part that's there. So once you have converted it to the standard form, 1 plus something or 1 minus something, first term is 1. You just look at the second term. The second term has to be between -1 and 1. Okay? Is that all right? Okay, good. I'm going to continue with this question number 11 and the graph question that we skipped earlier in the second part of this class around 9 p.m. or 9:15 at max. But for now, I'm going to end this class. We have to pray Maghrib as well, and it's already 14 minutes past 7. So I'm going to start M1 in about 5-10 minutes. I'm going to end this class for now, and we will complete this paper around 9:15 p.m. inshallah. All right. Allah Hafiz everyone, and see you again in the next part inshallah.